Okay, we're going to look at part D and part E on this problem, and this is a normal distribution here, and it says that 67% of the students went to college, and then a sample of 27 were selected. And so we've already calculated the mean, the standard deviation, but we're going down here to the probability that more than 20 of the 27 will go to college. So the first thing I like to do is to kind of draw what we're looking at here. So first of all, we had found that the mean was 18.09, and so we're wanting to find the probability that more than 20 students will go to college. So more than 20 would be to the right here. Let me make this a little bit smaller. More than 20, let's just say it's right here. So we want to know the probability that more than 20. Now, as you can see, they are not wanting you to use the table, because if they want you to use the normal distribution table, they will have it as a link. So if you're not sure how they're wanting you to work this one, then just go to part D. So I'm going to skip all of this and go straight to part D. And part D is where what we're going to do is, since this is since we're looking at more than 18, since it says more than 18, we don't want to include 18. So more than 20. We don't want to include 20. So our right boundary, we want it to be 0.5 above that. So we are wanting to start not at 20, but add 0.5 to it. So 20.5, and that is just the rule if you're doing more than. So what they're wanting you to do is to use Excel. So what we can do is we can go into Excel, we can put equals norm dot dist and enter X, which our X is going to be 20.5, and the mean, which we already calculated, was 18.09, I believe. The standard deviation, which you also had calculated, was 2.443. And then cumulative, we want it to include everything. Remember that the distribution table, when it gives you the probability, it's going to be the area under the curve. So we want it to be everything up to this point. So we want to put true. So click on, you can probably just double click there. Now, this is the number, this is the probability under the curve. So to find the area of this side, you have to say 1 minus this area. So don't try to round yet. Do equals 1 minus and select this cell. And here is our answer. Now, I believe we need to round to 4 decimal places. So if you were to round this to 4 decimal places, 1.1619 would be your answer. Now, I know it says 0.1620 is the answer, but if you click on this, it gives you a little leeway here. These are all the correct answers. So my answer of 0.1619 would be marked as correct. Now let's look at the probability that 14, 15, 16, 17, or 18. So this time, we want the probability, we want it to include 14, 15, 16, 17, and 18. So what we need to do in order to make sure that all of those are included, this boundary, we need to go 0.5 below 14. And then this boundary over here, we need to go 0.5 above that the right hand boundary. Now, when we put this into Excel, first we're going to find the probability all the way up to 18.5. So let's do that. So equal norm dot dist. Same, this time x is going to be 18.5. Your mean is still the same, the 18.09. Let's see, 18.09. The standard deviation is 2.443, and then cumulative. All right, there's that number. So let me make sure I put this in right. 18.5, 18.09, 2.443, and true. Now for your for the 13.5, what we want to do is find the area up to 13.5, because what we're going to do is that area, we're going to subtract it out. So let's see what that 13.5 would be. So we're going to do norm dot dist 13.5. The mean is, let's see, 18.09, 2.443, and true. So now we're going to take the area up to 18.5, which is this, and subtract out the area below the 13.5 because we don't want to include that. And so we end up getting 0.5365. And that is the correct answer. So it's all about not rounding your areas until you get your answer. And so the tables won't work here. They may work for some, but it may be off too much for other calculations. So when you see the example and they ask you to use Excel, be sure that you use Excel on these. Why do we have some that we use Excel? It's just to help you understand in statistics how to use the table, but to know that also Excel is another statistical tool that can really help you with these calculations. So let me know if you have any questions on Part D or Part E.